Hi folks, welcome to our second installment of our trauma series, Sharp Force Trauma. This is any implement that has a blade on it. This includes power tools and knives and swords and machetes and axes and everything else. So all of those things would be classified as tools. So really what we're looking at here are tool marks. These are the marks that are caused by the tools upon the softer tissue, which is, in this case, bone is softer than the metal that's hitting it. Before we get too far, I want to use as a comparison between blunt force trauma. Now, we've talked a little bit about blunt force trauma before, and we'll talk about it more in the future, but blunt force trauma on the cranium in particular, but really all over the body, is a strong thing. To bash somebody with some implement usually requires a fair amount of strength. Because of that, we tend to see these things coming in, hitting the body at similar angles. It's usually right to left or top to bottom. But the vast majority of it will be hitting the victim on the victim's left side. The reason being, the vast majority of people are right-handed. Thus, over 80% of the population is right-handed. So usually the victim will be hit on the left side, but there are exceptions. For example, if the attacker is behind the victim, then we'll see them hit him on the right-hand side because they're both facing the same direction. Or we'll see a few that are coming straight down on top, or the occasional double-handed switch thing. So handedness has a very obvious effect because it's a strength attack. Conversely, blade cuts come in at all different angles because I don't care how good of a martial artist you are. If you get into a fight with somebody with a knife, you're going to get cut. So the cutting implement really is not a strength weapon. Now we've got something that can come in any angle, going willy-nilly, up, down, side to side, front to back. Doesn't matter. Both left and right sides are affected, and of course, handedness does not have an effect here. So blunt force trauma, especially interpersonal violence blunt force trauma, is almost always to the left side of the head, whereas sharp force trauma can be literally any angle. So the side doesn't really help narrow down who did this. But the nice thing about bladed weapons is they will leave a mark on the bone that will correspond with what tool made the mark. These marks are called kerf marks. So different blades will leave different style marks. For example, with a knife, you can have a compound bevel, dual compound bevel, a V-edge, a convex edge, a hollow edge, or a chisel edge. All of these things will define how the knife cuts the bone. You'll see the match in the bone. Similar to knives are saws. Saws and knives will both do the same sort of idea with a different outcome. Let me explain. First of all, both of them are going to have a both downward and horizontal motion, right? So if you're cutting into something, you know you press down hard. Think about cutting a carrot on a cutting board. But then sometimes you'll saw it back and forth as well, like when you're slicing something. Well, both with a saw and a knife, we get both of these motion movements. But power tools and hand tools work very differently, and different styles will show us different things. For example, with a knife, it's forcing a wedge shape into a solid object. So you're going to see two things happen. The first is along the edges here. Now you've got this wedge shoving its way into a solid object. So the solid object has to go somewhere. So the first thing that's going to happen is it's going to cause this kind of ski jump idea. It's going to push upward because it's being pushed outward. There's nowhere else for this volume to go, so it goes up. So we see this distinctive up shape on knife cuts. But there's one other thing that we'll tend to see, especially on a relatively dull knife, where the knife will come in, this area is being forced apart, but all of this was once a solid object. So you're going to see cracks forming on the subsurface where these horizontal pushing of the wedge is going to force this over and it's going to break away. Does that make sense? So knives have this very distinctive pattern. There is similarity with the larger things like an axe or a sword cut, but there's also differences. So we'll show you those in a second. This is a typical knife blade cut where you see, obviously, this is very fresh bone. You guys can see that clearly. But it's forced its way in. It's wedged its way in. It's forced these sides open. You can see this ski jump starting. It's hard to see because it's a two-dimensional image, but you guys can see the coloration difference here, where it's swooping up there. You can see this little shadow here. Very typical knife blade on wet or fresh bone. Conversely, different blades leave different marks. Saws are very different animal. Here we have on the left-hand side, I'm going to draw your attention to this picture first. Here's a close-up of the saw blade. Luckily, the sun was hitting it at the side, so the side of my vise shows you what the saw looks like from the side. Very familiar saw pattern, right? We're all used to that. But what I want to draw your attention to is because the way saws work, you'll see this tooth goes off to the right. This tooth goes off to the left, and right and left and right and left and right and left. So you get this wave of the teeth. Now, this is what we're looking at. This part of the blade is not where the teeth are. This is the main part of the blade down here, okay? Then, where the teeth are, you can see there's a channel down the middle. And the teeth are actually cutting out to either side. This forms a different bottom shape in the cut. And I'll show you alternative kerf cut shapes in a minute. But what that's showing us is a saw will have this distinctive shape. And look, if it's cut out to the side, we have the sides of the cut coming up here, right? So they go up, they come across, and then they go whoop, up in the middle again. What we have is a W shape here, and I'll show you it much more clearly when we look at the kerf. But this way you understand how the saw is causing that to happen. So on our left-hand side here, we have typical blade marks made by certain tools. For example, the V shape down here at the bottom. That's our most typical knife shape, right? You've got a knife blade coming in, and it'll wedge something apart, have this sharp edge here. Conversely, square with round corners, this is more like a circular saw or a power tool here. This would be a worn power tool. This would be a brand new blade right here. Okay, very squared off. Lastly, we have this round U shape here on this side. This is typical of a relatively dull knife or blade, or more commonly, something like an axe or a hatchet, where the blade isn't very sharp, but boy, it's got a lot of momentum behind it, a lot of weight. Conversely, over at the other side, we have our convex profiles. These are really common in a saw. So here's that W shape I showed you just a minute ago when we looked at those alternating saw teeth go down to either side, right? Now we have what's called a truncated W, and that's where the saw teeth might have a third tooth right in the middle that chips out this middle part. Now keep in mind also, the wedge-shaped action of things like knives, swords, and axes is very different than what a saw does. A saw breaks away small pieces in this very distinctive pattern. It knocks out chunks, whereas the blades slice through or force apart. These are pulling away bits and bits and bits. Okay? All of these will leave a very clearly distinct pattern in the cut. Let me give you some examples. Here, do you guys see this very clean, very the two are very parallel to one another. These are two separate cut marks, okay? But I want you to look at how cleanly parallel the sides are to each other. You can compare that to up here. See how wavy these sides are? Any idea why that is? Look at how parallel these sides are and how wavy these ones are. This is your typical power tool. It's spinning at a high speed or moving. The blade is moving. It could be reciprocal. It could be all kinds of things. But it's going at high speed in one direction. The one over here labeled C, this would be your hand tool. So keep in mind, as you're sawing back and forth with a saw, your hand is going to turn side to side as well. That's what's happening. So the saw is cutting here, then it's cutting here, then it's cutting here, then it's cutting here, then it's, it's wiggling. So you can see my hand is going back and forth on this side while I'm sawing. So here I'm sawing this angle, then I fix it a little bit, and I saw on a straight angle. Then it comes over here a little bit, and I go to this more leftward angle. That's because my hand is traversing here. That doesn't happen as often with power tools. Now, some power tools do this, like chainsaws, like handheld power tools, or reciprocating saw, which is known as a sawzall. That's their typical name for them, where you can get a little bit of wiggle, not nearly this much, but you'll get a little bit. This would be typical of a handheld power saw. This is a benchtop power saw, or more commonly like a circular saw can do this too. Okay? Now, saws will leave clearly distinctive patterns depending on the blade that made them. The biggest thing is you'll notice there's something called the pitch of the blade, meaning the blade has a certain amount of teeth per inch. Okay? It's called TPI. So here we have much lower TPI than here. We've got way more teeth per inch. Here we have fewer. Okay, like here we have probably 16 or so. Here we have like 4. All right. Then how far the blade pitches from side to side. This one's way pitched very wide. Got a 2 millimeter pitch here. Here you've got about half that, maybe a 1 millimeter pitch. Here you have an offset pitch. And here you've got virtually no pitch at all. This is typical of like a hacksaw, which is like a metal cutting blade. Tends to have a very kind of wavy cut, whereas you've got this really side-to-side cut on a more typically with a wood saw. Okay? You don't have to know any of these things. I'm just showing you the differences in some of these things. So we can also see in a saw cut, we have these very smooth edges. They don't lift up like what we see with a knife, right? We don't see this big ski jump happening up here. Here, the saw, remember, it's breaking out chunks and working its way down. But we can also see if we have a worn or dull saw, it tends to break erratically. So you'll have bits and pieces breaking out. You can also have different things in the teeth that are showing up in these lower things, but I'm not going to pay too much attention to these two right now. Now, to discern the difference between what type of power tool could have made these things. First of all, I showed here, here's a bandsaw. For those of you who aren't familiar with power tools, this saw has a thin metal band that goes around these two wheels. And the saw itself is here. This goes all the way around, up and back down. This is where the cutting is done. It's in a straight line, always going the same direction. This saw spins like in this direction. I'm trying to do a circle here. There we go. So it's going to come down and cut. And then on the back side, it comes back up and then comes down. So all of the cuts are going to be made at the same speed, same direction, same angle. Nothing's changing. That bone can be pushed across this saw, and it's going to do this. Look at how clearly even these striations are. First of all, you're not going to have any of that wandering from side to side like we have with a handsaw. You're not going to have a false start, which we'll talk about in a minute. It's just a clean cut. And furthermore, you're going to see all of these angles on this saw from the cut end. I don't know if you know this, but we're looking at the cut end of a bone here. Here's a long bone. Okay, we're looking at it edge on where I made the cut. Okay, so here we have these very clearly unidirectional, single directional striations, and they're at a very even spacing, all going the same direction. No movement, nothing, very mechanical. Here's a striation, here's a striation, here's a striation. They're exactly the same distance because the speed didn't change, the angle didn't change, and the blade is always going in the same direction. Okay? Conversely, a handsaw, just like moving side to side while we make that cut, we're also moving up and down. The angle, think about the pitch angle of the tip of the saw is going to go up because you're going to put the handle down a little bit on this cut, up a little bit more on this cut, up even higher. So you see these different angles. You see this, and then this, and then if you're going like this, it's going to go all these different angles. Just like side to side, it's going up and down at different angles. The other thing that you will almost always see with any hand tool. Now think about this, and the easiest way to think about this, if you've ever cut a stick or a 2x4 or something like that with a handsaw, several things happen. First of all, you change direction a lot, both side to side and up and down, right? The last thing is when you get down toward the bottom of the cut, what's going to happen? It breaks. This is called a breakaway spur, and here it is. This is the part that breaks after you're done. You've cut from here down, cut all the way, and then snap, it breaks off. This is very typical of a handsaw. So we're going to see all these different directions, okay, of the striations, different lengths of striations. They're nowhere near as uniform. And a breakaway spur. This is typical of a handsaw. The other thing that is extremely typical of some power tools, but almost all hand tools, is what we call a false start. That's where the blade skips across the surface. So you start your cut here, and then it lifts up a little bit. Then you start here, and then it bounces over and cuts here, and then bounces over and cuts here, bounces over here, and finally makes purchase. And then you start cutting, right? And here's our breakaway spur. You got sick of cutting about 2/3 of the way through and broke it off the rest of the way. Done. Right? You'll see these with blades as well, like knives. You'll see a false start, but you don't see it very often with hatchets, axes, or sword cuts. This includes like a machete. This is where it's coming in fast with a lot of weight behind it, and it will do one of two things. It will either chop through completely the object. You've got one slice, no striations going back and forth like with a saw. It's just whack, cut in half, right? But sometimes you'll see one that doesn't go all the way through. So you may have whack, chink, and then wham, and it goes all the way through. On those false starts here, where you're whacking into it, you'll see two very distinctive things. First of all, you're going to have that lipping like you do with a knife, where it lips up, that ski jump on the surface. But with axes, hatchets, swords, machetes, these large blades where you're hacking through, you're hitting it. When you pull the blade back out, what often happens is the deep part of the blade acts like a lever, and it will break away this edge here, and you'll see this lifting going the wrong direction. This is lifted out, or you'll see it broken away. So you have a clean cut here, part of a clean cut here, and then it breaks away the bone. That's from the twisting action of trying to remove the blade and go in for your second hit. Okay? Piercing damage is very interesting because piercing damage clearly shows the outline of the tool that made it. Now start thinking about like fireplace pokers and things like nails or spikes of any sort. Now these things are going to stab through, and in the cranium it's really obvious because it's a nice smooth surface where they're making their hole. You can clearly see these are square shapes. This is a diamond shape. This is probably more like a sword stab. We've got a sharpened edge, and then a wider, thicker part through the middle. Here's a triangular blade, which is typical of something like a bayonet or something like that, okay? Round hole up here. But it's not a gunshot wound. These are things like arrows, spears, fireplace pokers, stabbing things that poke through. Now, you can do this with a knife. You can see a knife blade will do the same thing, but it'll have more of a triangular shape like that, right? Where it stabs in, okay? With this individual, what happened? Well, 2 hits that are very obvious here with a very large implement. I've cheated a little bit here because this is a medieval era skull. But the look is the same. Remember, weapons are backward compatible, like we talked about before. So this is actually done with what's called a halberd or a pole axe. This is an axe blade on the end of a long, usually like nearly 10-foot, 6 to 10-foot pole, which gives it a lot of momentum, a lot of power on these strikes. So the blade cut through this person's face. You can see the bending up here, the splitting of the metopic suture here. This tells us it's what? Pre, post, or perimortem. Bending, separation of sutures, that's perimortem, right? That's fresh bone that this went into. It smashed across this person's face, probably killed them. They would have fallen down head first. This is probably a coup de grace. Just make sure they're dead, whack them to the back of the head. So this is, again, from the side, an axe strike from the side over here. They're coming across, and it's the end of the strike shows you these radiating fractures coming down. We've still got bending. We've got radiating fractures coming out of the sides as well. Okay? Typical big axe. A very, very powerful person could probably do this with a blade like a machete or something to that effect. What caused this? Well, this is clearly taken from the same image that we had, that composite image of all the different piercing strikes. This is your square spike of some sort. Think here things like railroad spikes, fireplace pokers, I don't know, whatever you can think of that would stab into somebody. Usually a larger implement. This is clearly a big, thick thing with a lot of force behind it, but it shows you exactly the shape of what we're looking for, which is kind of cool. What about this? What do you think caused this? We've got bits of bone inside. We've got one side that's sliced, another side that is clearly cracked away. And we have this subsurface horizontal cracking. This would have been your machete, your sword. Probably not an axe or hatchet because it's too narrow. So what we're talking about is a large bladed instrument used as in a chopping fashion. Okay? All right, till next time. Next time we're going to go start talking about, I believe, gunshot wounds, which is a super interesting one. I'll talk to you then.